Question 7. The diagram shows a circle with center O and radius R. The angle of the minor sector A or B of the circle is x radians. Then the area of the major sector of the circle is 3 times the area of the shaded region. Show that x is equal to that. Now you can see that here x is expressed again in terms of x. So that means to solve this equation, we cannot solve it using the usual algebraic methods, but then we can solve it using numerical methods. So expect the next part to be from numerical methods. Now this one looks like circular measure, which you did in paper 1, but then some people think that it doesn't come back in paper 2. Now it is, paper 3, it is here. So we just need to use what they have given us. Area of major sector. Area of major sector is equal to 3 times area of the shaded region. But then how do we get area of the shaded region? The area of this shaded region is going to be area of this sector, then minus area of this triangle. Okay, so we can have, this one is going to be 3, then times, I can say area of, since they have said major sector, then this one is the minor sector. Okay, so area of minor sector, then subtract area of the triangle. Area of the triangle. Now, area of sector, you know that it is a half r squared theta. So we shall have here a half, and then the radius is of course r squared. The angle, so since this is the major sector here, then the angle, this arc subtends at the center of the circle, is going to be 2 pi. Remember, angles at a point add up to 360 degrees. So 2 pi, then minus this x here. Okay, so we are going to have 2 pi here, then minus the x. Then we come to this side. This is 3 into area of the minor sector. It is going to be a half. Then r squared, the angle subtended, is this x here. Remember, the angle has to look like the arc. Okay, look at this and look at this. But then for the major sector, do you see the angle has to also look like it? Keep note of that. Now, here we are going to have x, then minus area of the triangle. Area of the triangle, which is not right angled, you just need to get the sides which are forming an angle. So that will be a half, then times r, because this one is r, then sine of the angle in between, which is x. Okay, now from here you can see that I can actually pull out the a half. Okay, this is r squared over 2, then this is 2 pi minus x. When I pull out this r squared over 2 also here, I'll write it like this: r squared over 2. Then here we shall have times 3. Then here I'll have a 1, and then here sine of x. So this one will actually cancel with that one there. Okay, then we have 2 pi minus x, which is equal to, by the way, pardon me, here there is an x. There is an x here, okay, which remained. So we shall have 3x, then minus 3 sine of x, because this 3 is going to multiply everything there. So from here we can simplify this. Maybe I can have 2 pi, then minus, when this one crosses, it will be plus 3 sine of x, which will be equal to 4 of x, because this one, when it crosses, it's a plus, right? Now, one of these x's is made the subject. Is it this one or this? If it is this one that is made the subject, then we shall see an arc sign, but it is not anywhere. So it is this one that has been made the subject. Okay. So therefore we divide all through by 4. So x here is going to be equal to 2 pi divided by 4, then plus 3 sine x we also divide by 4. Therefore, your x is going to be equal to, let me write it exactly as it is, 3 over 4 of sine of x, then plus, of course, this one is going to be a half of pi. So that is that. Now, part B, show by calculation that the root of the equation in A lies between these two values. Now, what we can do is to get a function from what we are having here. So I can put everything on one side. I can say, let this one come this side, or the x go this other side. Okay. So from there, then I can substitute, I get the function. So we can have 3 over 4 sine of x, then plus pi over 2, maybe minus x. This one is equal to 0. Now I have a function in terms of x, because the root is when you get this function, you solve it, and then you get a 0. So a root is that value of x you're going to substitute in the function, and it reduces it to 0. So we shall have 3 over 4, then sine of x, plus pi over 2 minus x. So what do we get when we put a 2 here? So that would be 3 over 4 sine of 2, then plus pi over 2 minus 2. And then what do we get when we put 2.5? So this will be 3 over 4 sine of 2.5, then plus pi over 2, then minus 2.5. So what do we get here? What do we get here? We expect the answer, one of them to be a positive and the other to be a negative. Why? If I have maybe this as my graph, and this is the root here, that is where it cuts the x-axis. There is an x value here. Let's say this is x2. There is also an x value here, which is x1. So when I substitute it in the function, I'll see a positive value here for the function because it is above the x-axis. And then here, the value of y here is going to be a negative. Okay? Here the y value is a positive. Now, so if the root is in between two values, those two values should give two different answers. Okay? They should give one being positive and then the other one is a negative. And then another thing here, the calculator must be in radians because we are seeing the trigonometric functions. Okay, so calculator, every time you see the trigonometric expression in numerical methods, always put the calculator in radians. Now we have 3 out of 4 sine of 2 here, then plus pi over 2. My calculator is already in radians, then minus 2. I'm going to write like to 4 decimal places. 2528, 0.2528. Okay, then how about 2.5? I'll just come here wherever there is a 2, I put 0.5, and also this other one I put 0.5. Then we have a negative, so that is negative 0.4803, 0.4803. So you can see that this is positive, this is negative. Okay, then we conclude that since there is a change of sign, since there is a change of sign, okay, for f of 2 and f of 2.5, therefore, then I just write this: the root lies between 2 and 2.5. Part C. Use an iterative formula based on the equation in A to calculate the root correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Now, here we are going to have, since it is in between these two values, 2 and 2.5, they have not given us the initial approximation. You can take the initial approximation to be any of them, maybe a 2 or a 2.5. But I usually recommend that you take the one that is exactly in the middle of the two, okay? So let the initial approximation be, let's say x1, which is going to be 2, then plus 2.5 divided by 2. This one will automatically give us 2.25. Okay, then what will be x2? So x2 is now going to be, we are substituting into this one here. Okay, here 3 over 4 sine x, then plus pi over 2. Okay, so we come to this one here and we say this one is going to be 3 over 4 sine of x now, which is 2.25, then plus pi over 2. What do you get here? Then after showing the examiner that you have substituted in the first one here, you don't need to show the next substitution, writing all of this. You are wasting time. All that you do right now, x3, what is x4, maybe x5, maybe x6 or x7. I've just written this. We shall see where to end, whether we end here or before that. Now we are going to have 3 out of 4, then sine of 2.25, then plus pi out of 2. This one, we are supposed to give each value of the iteration to 4 decimal places. So this will be 2.1544. 2.1544. Now this value here is what I'm going to put here. Okay, don't go to your calculator and you put sine then answer here, so that it remember this one is just a rounded figure. Okay, so when you do that, sometimes it fails and many times it fails. So just pick this value, you put it in the equation. So I will come here where there is 2.25. I'm just going to put 2.1544. Now I get 2.1967. 2.1967. Then the next one, 2.1967. 967. That is 2.1786. 1786. Maybe the next one, 1786. 1786. This one is 2.1865. 2.1865. Now, when do you know that you're supposed to stop? You must get 3 values that are rounding to the same figure. Okay, correct, to 2 decimal places. This one here will give me 2.20. This one here will give me 2.18. This one here is 2.19. You see that? 2.19. Now that means I have to proceed. We have 2.1865, 2.1865. That is 2.1831. 1831. Then we put it back here, 1831. Then we get 1845, 2.1845. Remember, this one gives us 2.19. Then this one here is giving me 2.18. This one is giving me 2.18. Now these two are giving me the same value. So this becomes the minimum number of iterations I'm supposed to do. So I need to do one more to give me the third one that confirms this value, because you can get the next one when it is giving you maybe 2.19. Okay. So the minimum number of iterations then will be these 7. Okay. So we are going to add on one more. So that means x8 here is going to be 2.1845. That is 2.1839. 2.1839. Now these 3 are all giving me 2.18 to 2 decimal places. So this therefore means that the root x, okay, the root is going to be equal to 2.18 to 2 decimal places. That is that.